Okay, cool. This is actually a very light presentation, so it's perfect for lunching. No brain melting or anything, no math, no formulas. You're totally cool. So yeah, my question to start this presentation is, wouldn't it be cool to have even more control over your ground control station? And I ask that because our users think so. Actually, they kind of need more control over their GCSs. Many of our users in Blue Robotics, they have many cameras, many sonars. So you have all kinds of cameras, USB, IP, also sonars, multi-beam, unidirectional. They have all of them, and they need all of them in their missions. Also, our users, some of them need more things on the screen. Some of them need less things on their screen. Actually, all of them agree. All of them disagree on what to have on the screen. If you ask 100 users what they need, they will answer with 100 different answers. But in the end, they've been asking for more control. And that's why we started this project. That's why I'm going to present to you today Cockpit. My name is Rafael Lehmkuhl, very different in English, difficult to pronounce. I'm a software engineer at Blue Robotics. Today I'm going to present you Cockpit, which is our highly customizable ground control station, a project that we've been working on for some time now in Blue Robotics. So the thing with GCSs is that they are hard. They need to do many things. They actually need to have an infinitude of functionalities, but at the same time, they need to be maintainable. That's a usual problem with big complex projects. Because of that, and to be maintainable and at the same time having that many functionalities is hard. You have to support many OSs, you have to support many topside devices, firmware, protocols, missions, vehicles. There is an infinitude of things. The thing is that the ground control stations that exist today on the open source market, and I'm mainly talking here about Mission Planner and QGC, they were successful because they were able to check many of those boxes. If you look at Mission Planner, it tackles more the functionality side. So we can basically Mission Planner implements basically everything that exists in our pilot out there, while QGC tries to go more on the user experience side, although being less configurable. But yeah, so the question that we've been asking ourselves is, what if we try to have the best of both worlds? What if we try to check all of those boxes? And that's basically how Cockpit started. Cockpit is our answer to that question. Cockpit is a completely new ground control station. It's free and open source. Code is there on GitHub right now. It's been in development for 2 years already in Blue Robotics. We've been thinking about that, about Cockpit for a long time, actually. 2 years ago is when it actually started. We had our first stable release, 1.0.0, back in August this year, so 2 months ago. It's really, really new. And Cockpit has mainly 4 key points that I will talk a little bit about. So Cockpit is based on web technologies. It is configurable. It has a widget-based UI, as we are going to present. It supports calls to generic APIs, and it also supports generic data sources. I'm going to talk a little bit more about each of those points to explain why we see those are as important and why do we see those as what makes Cockpit different. So first of all, the most basic point, but at the same time, one of the most important points, Cockpit is web-based. The stack is completely on web technologies. And why is that important? There are some reasons. First one, web technologies today, they are on the core of most of the applications that we are dealing with. Probably most of you code on Visual Studio Code. Maybe some of you, I know that some use Emacs or Vim, but a lot of you probably use VS Code. And the thing with being based on web technology for that side is that we have a huge potential base of developers out there. So this helps a lot. The second point is that browsers are a powerful thing now. If you look back 10 years, it's totally different from what we have now. We have very good browser APIs today, very powerful ones. And as long as browsers evolve and are a thing, Cockpit will also be. And last, but definitely not less important point, we can write Cockpit once and run it anywhere, as Java promised a long time ago. And this helps us a lot. Being maintainable is a core thing on Cockpit. If we talk about stack, talking briefly, it's TypeScript, and really for a complex web-based project, types really help. I wouldn't start a big one today without it. It's based on Vue for the reactivity part. Although we are trying our best not to tie to Vue, and all the core modules are separated from Vue or basic TypeScript modules. So the Vue is more for the reactivity part. As Patrick presented yesterday, we use WebRTC based on Mavlink Camera Manager for video transmitting, and we use WebSockets for fast communication. Okay, we have two versions of Cockpit today. We have the browser version and we have the Electron version. So in the top, you can see BlueOS, which William presented 2 days ago. And you can see Cockpit running as a BlueOS extension, which is really cool. BlueOS runs on your companion computer, and from there, the user can just click on the Cockpit button and Cockpit is there. They don't have to install anything. It's pretty cool. And on the bottom, you can see what we call the best setup today for dealing with ROVs. It's a Steam Deck. Probably many of you have one connected through USB-C to our Tether. And Cockpit is running there with Electron. That easy, really light setup, really easy to use. So the thing with web technologies in the end, being web-based, the cool part is that we're here to stay for a long time. That's the whole idea. Second point, and probably what calls most attention for you that know Cockpit already, is that it's completely configurable. It has a widget-based UI, and you can basically make it anything you want. We have today two types of widgets, regular and mini. You can see there the virtual horizon one and the compass, they are both regular widgets. And the other ones are what we call mini widgets. As I said, everything is a widget. The clock is a widget, the alerter is a widget, the notifier is a widget. Those things are widgets. It's completely configurable. And widgets can be as simple as a depth indicator that is there, or as complex as a map widget, which actually connects to a lot of sources, needs to have a lot of abstraction layers, etc. Although the depth indicator there, it's around 5 to 10 lines of code. It's pretty simple. And one widget is probably the most important one in Cockpit, and is what makes it different from the start. It's the video player widget, actually. So you can see there on the screen right now, we have Cockpit running with three different streams. As you can probably see, they're not from the same mission. I just took from different missions and streamed that to Cockpit to record the slides. But you can see three video transmissions at the same time there. So how many can you have? As many as you want, basically. Today, many of our internal users have 2 cameras on their ROVs. Of course, a lot of people have just one, so it's cool. We have users with 4 cameras at the same time right now. So you can have as many as you want. It's really, really cool. And this was basically the most important, the first demand that we tried to supply with Cockpit. Being web-based helps a lot. Being widget-based helps a lot. Let's think about missions. If you have different missions for the same vehicle, or if you have different phases on the same mission, you probably don't want to see the same thing on the screen for the entire mission. It doesn't make much sense. And the cool thing about Cockpit is that we can have as many views as we want. The user can configure just 1 view or 2 or 3, or they tell us. On the top, you can see the edit menu in action. So you can basically resize the widget, reposition it as you like. You can have as many indicators as you like, configure each one individually. It's really, really powerful. And on the bottom, you can see one of the cool parts of it. You can toggle between those views very easily. You can actually do that by the joystick itself. I'm going to talk a little more about it. So just draw your views and use them. Let's say that okay, views are cool, but let's say that you have many vehicles, or as many companies here operate, you have one vehicle with many pilots using that same vehicle. And the thing with pilots is that each one of those, they are users, and each one of those need their things. One prefers to have this kind of visualization. The other one prefers another thing. And Cockpit supports actually all of them because we support different profiles and different users at the same instance. So the cool thing about it is that, for example, Jess, on your example, can have a ROV and a boat profile, each one of those with their different views. And John can have its own profile, everything stored on the same vehicle. For different missions or in different vehicles, all of those. Everything today for the users that use BlueOS is synced with BlueOS, so you actually don't have to have your computer. If you use the computer of someone else, you can just connect to Cockpit on that vehicle and choose your user that is stored there. So it's really, really powerful. So the thing with being configurable, being widget based, is that we don't make the choice for our users anymore. They make their choices. We don't interfere. The third point is one pretty cool. I talked about being able to switch views with our joystick. This comes from something called Cockpit Actions. So the idea here is that we want to be able, and we are able today, to communicate and basically post commands or send output messages to different APIs. You can see the vehicle, the autopilot instance, as an API. But at the same time, the cockpit itself has its API, and you can have other APIs on your network. This is really common for us. I know that is different for people that don't use companion computers, but if you have one, you probably have a camera attached to it. You have a LiDAR. Many of our users have many sonars actually, and the thing is that a lot of those they don't necessarily need to be connected to the autopilot because their data is not going to be used to. It's not going to be dealt with by the autopilot. So why not to call them directly? Why not to use their APIs directly? So we have two types of actions, actually. we have predefined build time actions, the ones that are hard coded inside Cockpit, like the toggle to next view or toggle full screen, etc. But the user can also have dynamically assigned actions. They can configure their own during runtime. And one of the most powerful ones that we have that is actually a base for a lot of things is the HTTP request action. And the thing with it is that you can basically call any API. That is the cool part. So let's say that you have your camera, and your camera for ROV users is very common that during a dive, you have to do the auto balance, the white balance of your camera during the dive, because as deeper as you go, the color changes. Basically, the color that is received by the camera changes. So you need to redo the auto balance. So with Cockpit Actions, you can create an action that calls an API from your camera and just redo the auto balance for it. HTTP request actions are really powerful. You can change the URL that you're calling, the HTTP request methods. You can send a body JSON. You can send URL parameters. Really powerful. Change the headers, everything. And a very cool part is that you can see there, you can actually not only have predefined hard-coded URL parameters or body messages, you can dynamically define them, actually. So let's say that, for example, you want to send a joystick state to one of your APIs. Let's say that you have many sliders. You have one of those fly joysticks that have extra sliders, and you want to use one of them to control something that is on a separate API. It's not on the vehicle. You can do that here. The URL parameters and the JSON body, they are dynamically generated based on a pub/sub architecture with variables that are inside Cockpit. And actually, this is already being used. What you can see there on the screen right now is something very cool that we are merging between this week and the next. That is called generic input widgets. The cool part about it is that we don't have to, as we allow the user to configure the actions, we also allow the users to configure the widgets. So let's say that, for example, think about the camera again. Let's say that you want to control the brightness, hue, or saturation of the camera during the mission. What our users usually do is that they have Cockpit running, or they have the GCS running on one window, and they have another window on the Alt tab that they are going to switch to basically change the controls of the camera. They don't need to do that anymore. Here, they can just configure 3 slides, connect those slides to a Cockpit action that calls the camera API, and all of a sudden, they can control their camera from inside Cockpit, from inside their GCS. So it's really nice. For sonars, for example, anyone that works with sonars know that you usually change the gain during the mission. You can do that from here now. So it's pretty cool. So this is the third point, and it's a very cool point because it basically allows Cockpit to deal with any device on the network that you have available. It's pretty powerful. Fourth, and last but not least, that's what I had written here, is the flexible data input, which is probably the one that we are most behind, but it's something that we really want to tackle in the next months. So let's think about having many sensors again on the network. You have your Autopilot vehicle that is streaming a lot of data to your GCS. But if you have extra things like cameras, sonars, other things, you want to consume from them on the same way. And the idea here is that we are allowing the user to basically consume from any data source inside their network to route this data to inside the ground control station and show them on the widgets, use them on the actions, basically log them, do anything. A very common application that we see on Blue Robotics are people that are using our ROVs, but are developing their own sensors in parallel. So for example, Kurt, which is one of our application engineers, he has an ROV, but he developed a Arduino-based pH probe. But the thing is that to connect this to the GCS, he had to basically do a very long path. With the idea of flexible data inputs, we are going to short this path by a lot. The idea here is to allow the user to consume JSON-based and also string template-based data sources, allow them to write this parser, or in the case of JSON, to just select what is going to be consumed and how, and inject this data inside Cockpit for them to use. What we have today to do that, we started with segregated modules. So ArduPilot / Mavlink are different modules inside Cockpit. So we tried our best not to make Cockpit completely based on the ArduPilot and Mavlink specification to allow those different data sources. But of course, mistakes are made. We probably have some things here and there really tight. But the idea is to make the GCS more powerful, is to allow them to connect to different things. And one of the cool things that we have today that is on this path, is not finished yet. This one is working. You can use, probably all of your users use this already. Is the very generic indicator. So you can basically define an indicator for anything that is being streamed to your GCS today. The only things that are streamed today are the ArduPilot data and BlueOS data. But as I said, the idea is to extend that to generic data sources. So with the very generic indicator, for example, you can take any of those variables that are inside the string, define how they are going to be formatted, parsed. The unit is a problem. So our idea for that we are prototyping, and it's not ready yet, but is to use file system like paths and with unit and tag information. Why that? Unit basically because it allows the user not to configure anything related to units and just use them and convert between units with a click on Cockpit, everything at the same time. But also tags, because the idea here is to allow you to have any widget that could consume from that data source to connect to it. So for example, let's say that you have a depth indicator there. Today, it's directly connected to the depth that is censored by the vehicle instance. But let's say that you have a separate instance, a separate sensor like a unidirectional sonar that you can use to measure depth. You could directly connect to the very generic indicator in that way. So it's really, really powerful. So fourth point, the idea here is basically to allow the user to consume from anywhere and basically this extends their possibilities to the infinite. So to wrap things up, where we are and where we are going to. So today, as I said, we have complete support for ArduPilot and Mavlink. I'll talk about vehicles specifically. So we have full support for our submissions, and we are on our path to have full support for the surface boats as well. Those two, of course, because Blue Robotics works with ocean-based technology. So those are the ones that we are mostly dedicated to. But we have an initial support for our vehicles as well. A external contributor, Eric, helped us a lot with that. But I have to say that for anyone trying to use Cockpit with aerial vehicles today, if you don't have a companion computer with Mavlink server / Mavlink to rest installed there, you just have to install it locally on your computer. It doesn't come built in on Cockpit yet. Okay. The widget system is very mature. You can basically build any screen that you want with it today. The main thing that we are missing is the support for external widgets. So in Blue Robotics, we really like to work with our partners. We have many partners that create sensors, actuators, everything to work with our vehicles. And many of them need to have their own widgets. And some of them don't want to have the widgets directly built in on Cockpit. So the idea here is to support external widgets to be loaded. Our API for that is a prototype yet. We are developing some external widgets already, mostly Sonar ones, to test this API, but it's still a work in progress. Mission planning is completely usable already. Although, as I said before, Mavlink actions are still not a thing. So you have just regular waypoints. You can basically drive your vehicle to places and don't do anything. This is 80% of the missions usually, but that's what we have today. So the next step is to also have Mavlink action. So basically being able to configure any Mavlink message or command as actions inside Cockpit. And to not say I didn't talk about the flowers, which is an expression in Portuguese, but probably not in English. We have a very powerful joystick support. Basically, we support any gamepad that you have, name it. And we also support as many axes and buttons as you need. And this came actually from some of our users that needed support for those very fancy fly joysticks that have like 10, 12 axes and 30, 40 buttons. Of course, I don't think you can use all of them on Mavlink / on ArduPilot. I think we are restricted to 32 buttons. And today, 6 axes on ArduSub, but I don't know how many on the others. But of course, you can tie those buttons and axes to Cockpit actions. So you can control other things with it, like the camera, the sonar, etc. So it's really, really powerful. And of course, we have plans for the future. The next thing that we are going to work on are the dedicated Mavlink message actions to be able to support the surface boat and missions first class. We are on the development already of the external widgets, support for external widgets. This is an ongoing work. And we have a proof of concept for the generic data sources support. That is probably something that we are going to tackle on the first quarter of the next year. And we are pretty excited with it. And our Blue ROV users in general, the main thing that they do with their vehicles is recording. It's camera recording. So one of the things that we are tackling right now is video redundancy in the vehicle. We are developing a system, a service inside BlueOS that allows the video problematic videos. Let's say that you lost some chunks because of connection, or you dropped your topside computer device on the water. That happens, right, Craig? Sometimes this happens. And the idea here is to allow recovery of those videos from Cockpit, so they're being backed up. There is redundancy on the vehicle, on the companion computer itself. And to finish, we are also going to add a lot of Electron-only features because security context is a problem on browsers. So, and when you're running a extension locally, you don't have security context access unless the user goes through the hidden path of clicking the buttons that say that this is very dangerous. So Electron support, the Electron application is going to support a lot of cool things like full file system access support, webcam and mic for journals, and many other things. I would like to finish this presentation by acknowledging the really hard work of this great team that we have. This is the software team. It's missing Pascal here, and Rusty is there as a a a face. Cockpit is the work of many people. Especially, I want to thank Arturo, that is my colleague on the core cockpit team. Patrick, that started this 2 years ago with me, and that is building those tools that we use to make cockpit work. So Mavlink to REST, Mavlink server, Mavlink camera manager. João, that is the core maintainer of those tools today. William, Elliot, for the amazing help. With Dan, also the rest of the BR team that really helps with ideas, feedback, and everything. And I finish a special thanks to Rusty, which is a founder, believing in this project from the start, and believing in the team that built it. So that's it. Thank you very much. Open for questions.
Thank you for the talk. It's really refreshing to see the potential for new GCSs. I'm kind of bored with the existing ones. I'm not very familiar with web technologies. So my question is, what happens when you lose connection to your vehicle or have a shaky connection with your vehicle when your GCS is hosted on the vehicle?
Sure. As soon as you loaded the application on your browser, it stays on your browser. So it basically, you don't have problems with connection because it's running there. We are not streaming. We are not doing server side, for example, that is streaming code during the usage of the application. It's completely built and sent to your computer. But of course, for some reason you have to restart the application on your computer. That wouldn't be cool. The idea with web-based technologies is not to use directly in the browser. This is not the main goal. The main goal is to have all those extra things that I talked about in the beginning. So a huge developers base, being able to run anywhere, etc. So the main application that we are pushing for is the Electron one. So like use VS Code. Like you can use VS Code on the browser, but mostly nobody uses. The thing is, generally, you're going to push for the Electron app.
Thank you very much.
Great to see this new ground station. I was curious if this new web technology is going to give you ability to do some 3D maps so you can see where your vehicle is in relation to terrain, let's say.
Yeah, we have a really cool roadmap. I don't have it here. It's a roadmap for like 3 years in the future. We are seeing this kind of thing. So 3D mapping as well. One thing that we're discussing during the conference a lot is the ability to add overlays to the map. So the ability to for example, to load sonar overlays on the map, so you can see what is underwater based on previous missions or other users' missions, as well as photogrammetry, etc., being loaded to the map widget. So yeah,
awesome, thank you.
Nice.
Yeah, great work, and so fun to see all the ins and outs of it. I was wondering what the possibilities were to like run, if you would run Cockpit by itself, hosted on like a normal web server, or like accessing the vehicle over the web. I guess you looked into that.
Yeah, that is actually possible already. And there is a running demo that anyone can access on our GitHub page that is basically hosted on one of our servers. And I know that I don't have that much time here, but I can load cockpit here, and this you can thank William for that if it works. If it doesn't work, you can blame William as well. Users, we have users on this thing, and William, I hope this works, man. But it doesn't. He did a great job with the simulator. Oh, God. Maybe didn't. Okay, that's on me. But I will show cockpit just during that. But basically, the whole thing that I was telling you about. So, for example, the user access, being able to connect to any vehicle in the network, and even you asked about remote connections. You can just put your zero tier. For example, your zero tier address here. That means that you can connect your local cockpit instance to a remote vehicle through zero tier. Or you can also have the cockpit running on the server there and just connect to it here. So yeah, basically, I was going to show a simulator that is really cool, but as I can't do that right now, yeah, happens.
One last question. What map library do you use?
We use Leaflet today. What we are trying to do as much as possible on separated layers. We really don't want to tie the main functionalities to a library that may or may not be maintained in the future. Or totally flat is pretty huge, so difficult for that to happen. But yeah, we are using Leaflet today, and yeah. Better round it up back. Okay. Oh, sorry. It's working now. Okay, just a second. 30 seconds, Randy, just to show this thing. Oh, you're controlling? Okay. I will fake that I'm controlling, but it's actually William there. And this is good because William is an awesome pilot, and I am really bad at it. But yeah, this is cockpit running. It's running on a web server that is hosted on by us. And this is running instead of having a real vehicle with a real camera stream. This is a simulation. It's Bluesim that was built by Patrick and William. And cockpit is connected to it, being hosted there. Yeah, you can try to catch fishes and cool stuff with it. Oh yeah. Yep. You can just connect to the QR code there, look at our repository, try the demo, and open issues, and that's it. Okay. Thank you again. Sorry for the extra time.